One of the many challenges of building a guitar is bending the sides to the exact shape you need. And if you're using a side bender and you can't find the form that you're looking for, you're gonna have to build one yourself. Today, I'm gonna show you how to create a custom bending form on our ShopBot CNC. It's surprisingly easy, and once you've got the file, you can make another one whenever you need it. This is part of our Guitar Tech series, where we explore practical ways to use tools like CNC machines, laser cutters, 3D printers, and other technologies to make guitar making easier. All we're gonna need today is a piece of Baltic birch plywood, so let's get started. First, you're gonna need to get your shape into the software, and there's a few ways to do that. You can scan a paper template, you can take an outside mold you have and make a tracing, and a number of businesses online are selling CNC plans now, so that would make it very easy to import the shape. In my case, I'm lucky because I have a vector file of my Sedona model, which is my grand auditorium size. It's probably my most popular guitar, but I want to upgrade from the old style Fox system into the new StewMac Fox system that uses the 3 slats. So we're gonna start by basically setting up our work surface. I have a board that's about 21 inches by about 9 inches. And Baltic birch plywood is actually not 3/4 of an inch, it's actually 18 millimeters, which just is a shade over 0.7 inches. Boom, so there's our material. We're gonna put the datum in the center. And then we're gonna go ahead and we're gonna import our DXF. There's my DXF, and boom, there it is. There's the outline of the shape. Now, here's what you wanna consider. This drawing is the outside surface of my sides. But when you bend a side, it wraps against the form on its inside surface. So to get the finished body to come out to the right size, we actually need to make a form that's a little bit undersized to allow for the thickness of the side material. In my case, I laminate my sides. My combined thickness is right about 80 thou. So I'm gonna reduce the outside surface by 100 thou. That covers the 80 thou of the side, plus the bottom slat, plus the craft paper I wrap it in when I bend it. In V-carve, that's just an offset of the whole profile. We will take our shape, and then I'm going to come in here and I'm going to cut the vector in 2 places. So now what I've done is I've unhooked the top of the shape from the bottom of the shape. And the reason is then we're going to come in here and we're going to do an offset. And that we are going to offset this by 0.1 inches. Let's go outward. So now I have an inside edge that's smaller than my form. Okay, so let's go into our layers and let's create a new layer called template with offset. And let's actually take the imported shape and rename it as well. So we get template without offset and template with offset. And we get rid of these 2 layers that we don't need. All right, so I need to move this over to the new layer. Move to layer template with offset. There we go. Then we'll come back to our design software, and then we'll connect these 2 points with a line like so, and then we will join the vector. So we'll take those 2 lines and we'll join them together so we have just basically one shape, which you just do with the join vector tool. And now we have one shape that represents the offset size that we're going to build our form to. Your offset might be different. You might use thicker sides, you might use 2 blankets, you might have thicker slats. So do your own math here, but the concept's the same. Undersize your form by your side thickness and by your slat thickness. And if you do that, you will come out right on the money and your side will fit perfectly in your form. If you look at any of the StewMac bending forms, you'll notice that there's a notch directly below the waist. And that notch sits on top of a pin. And what it does is it keeps the form from sliding back and forth while you're bending your sides. Let's add that notch. So what we're gonna do is we are gonna find the lowest point in our waist, which is about right here, and then we're gonna draw a line straight down. Just make it go through our form, just like that. Then what we're gonna do is that we're gonna offset this. Remember, it's a 1/2 inch wide. So we're gonna offset this by 1/4 inch on both sides. So we go into our offset tool, we choose both. We wanna set that by 1/4 inch. There's our 1/2 inch right there. So then what we do is we'll go back into our design software over here. We're gonna make a small line at the bottom of our form. We'll get rid of that line in a second. All it's gonna do is just give us something to offset against. Then we're gonna offset that by 3/4 of an inch. and that's going to mark where the top of our notch is. So this is essentially where our notch is going to be cut out. Then, because the top of the notch is round, we're going to take the top line that we just drew and we're going to offset that again, this time by 1/4 of an inch, which will give us what essentially will be the center of a circle that'll have its tangent right at the top of that line. I think we're going to go that way. Okay, so we come back. We're going to draw our circle that has a 1/2 inch diameter. We're going to set the center right there. Boom. Okay. Then what we can do is just come in here with a trim tool and get rid of everything we don't need. We're going to get rid of that. These 3 things don't need to be there. That doesn't. You see what I'm doing? I'm essentially just removing everything that is not the notch we're going to cut out. Get rid of this guy. All right, so we are going to cut out this little guy right here. So let's go to our node tool. We're going to add a point. We're going to add a point here. Cut the vector. Cut the vector, and I know there's simpler ways to do this. Get rid of that vector. There it is. There's the shape that we are going to cut. Now we've got a whole bunch of vectors. We got a vector here, we got a little vector here, we got a vector here. So all these pieces just now need to be joined into one shape. So we just basically highlight them all and go into our join tool, join. Now we have one vector. And that's it. And we've just drawn our shape. And now we're ready to move on to creating our toolpaths. Here's our material. It's Baltic birch plywood. We've chosen this because it's flat, it's stable, and it'll stand up to decades of use. But Baltic birch, when you're routing it, tends to tear out on the top and the bottom faces. So to get the cleanest cut I can, I'm going to be using this. This is an Amana Spectra 46071K bit. 461. We're using this, an Amana Spectra 46170K compression bit. It's basically built exactly for this job. Here's the trick with a compression bit. It's got a downcut spiral up top and then an upcut spiral at the very tip. The downcut pushes the fibers down so the top face stays very clean, and the upcut shears the bottom fibers up towards your material so that face stays clean too. You just have to set your passes so the right part of the bit is doing the right job. I'm going to put all my speeds, feeds, and other stuff down in the description below, so if you are so inclined to cut your own, you've got everything you need. Let's get started. So we're going to open our toolpaths area, and this is going to be a profile toolpath. We're going to be cutting on the outside edge. We're going to be going, let's say 720 thou deep. Again, we only want to just cut through the material because we don't want to go too far into our spoil board, because we've got that upcut on the end of our bit. So we want to make sure that we're just using the upcut. So we're still in a very safe area right here. We got to go in and we got to set up a bit. So we go in, choose our tool. So we're going to go into select, and that we don't actually have a end mill set up for this. So we're going to go in here and let's create a new tool. And then we're going to make this, it's a 1/4 inch cutter. It's 2 flute cutter. Create our settings. We'll come back to that in a second. And then let's rename this as well. So we can come in here and we can create a new tool. We're going to call this an Amana Spectra 46170K compression. All right, so there's our bit. We are going to make the pass depth half the diameter of the bit. Step over 0.1 is fine. 18,000 RPM is good. We're going to use 55 inches per minute for a feed rate, 20 inches on the plunge rate. Tool number 1, that all looks good. We'll click apply. We'll select our tool. Okay, now to make sure that we get the compression part of the bit cutting the way it's supposed to, we need to make sure that each pass is cutting in the right place. So we're going to go in and we're going to edit our passes. So the way this particular bit works is the first 270 thou is the upcut. So we're going to set our first depth to be about 300 thou. So we're going to go in and we're going to set this, or actually let's delete this one. We'll set this one at 0.3, apply that. Then we're going to come in and basically add about 120 thou to 150 thou per. So let's go with this one at 450 thou, apply that. And then we'll do this one at, let's call this 600 thou. Oh, I see what the problem is. And then we're going to go 72. So we're going to basically cut this in 4 passes. First pass is 300 thou. Second pass is 450 thou, then 600 thou, then 72. We're going to say okay. And then now we have 4 passes. So then the other thing we're going to do, we're going to cut conventional. And conventional does not really give us the cleanest outside edge on the side of it. So we got a crisp top and we got a crisp bottom, but it doesn't give us the best side. It does tend to be a little better way to route because you have a little less chatter in that. So what we're going to do is we're going to go ahead and choose conventional, but we're going to do a separate last pass, and then we're going to make an allowance in that last pass of 0.010 of an inch. And on the last pass, we're going to reverse direction. So we're going to do a climb cut on the last pass to basically give us a very clean, very crisp edge on the outside. So this will just make the whole thing look nice. We are not going to use tabs. We're going to hold this down with the tape and super glue method, which we'll talk about in a minute. We are going to add ramps. So in this particular case, I want to add a 2-inch ramp to this bit, and that is it. So we're going to go in and just name our toolpath. So 01, outside profile, 0.25, up, cut, compression, end mill. Calculate. It'd be helpful if I chose a vector. It's going to cut the material, that's fine. Boom. And there is our outline that we're going to cut. So if we want to just take a quick look to make sure everything's going to work correctly, we can preview our selected toolpaths, and that looks pretty much like what we want it to look like. With that done, we can close that, and then we can save this out as a file that the machine can read. So we're saving this profile to our ShopBot Desktop MAX 8 with an ATC. But we're not going to be using the ATC. And then we're going to go into our file here. You're going to see my test file here, but we're going to make another one. Okay, so basically now we're saving this file for the machine. At this point, what we're ready to do is we're ready to move over to the machine, get our material on the foil board, set up the job, and then run our cut. So essentially, take number 20 super glue, and we're going to put a generous but not crazy amount on our tape. And then we will take some accelerator, careful not to get this on your glue, and then we're going to put this on our board. Again, you don't have to go crazy, just a little does a good job. And then just to help keep everything square, what I'm doing, I know for absolute certain that this spoil board is square to my table. So I'm just going to use the edge of it, line my edge up on my board. Just let that sit for a moment. Now that'll take a couple minutes to cure. At this point, our board is glued down and we're ready to turn the machine on. Make sure we've got air. We'll take our Spectra bit, load it up. And then we're going to find our XY0. And once we've got our XY0 located right above our center point, then we will zero our Z-axis using our 0 plate. And for this, I'm going to go ahead and put the dust shoe on, help us clear the chips. And the reason that I really want the dust shoe on, we're using a downcut bit, and I don't want to drive the chips into the channel with no way to pick them up. So I want to get them out of there as much as I can. Let's set up our program. And we are ready to hit start. Let's get the gantry out of the way and see how we did. First impressions, it looks amazing. And so here's what I'm looking for. That top edge right there, there's absolutely no fuzzies, nothing. There's no tear out of that top layer of the veneer on this. From what I can see, the sidewalls all look clean. And now that I'm looking down at the bottom, I can just see the tape. So we didn't cut into the spoil board below, we just kissed it, and that's good. Now, remember, the bottom of this has tape on it from the tape and super glue method, and that is also gonna help us preserve that grain. So I feel very good that we're gonna have a clean edge on both sides. So let's pop it off and take a look. All right. Looking good, good, good. Oh yeah. If you look, I mean, we have like nothing. I mean, this, what appears to be fuzz on the edge, that's just tape. So we have no fuzz on the edges. That's all very clean. The actual cut is very good. I mean, just a couple swipes with a sanding block, and this will be perfectly smooth. Yeah, looks amazing, looks great. So we actually need 3 of these for our bending system. If you look at how the StewMac bender system works, it actually has 3 of these that support the side all the way across, so it gives you a lot of foundation to bend your side on. So we will just essentially make this 2 more times. When we make the other 2, we really got a couple of choices. So choice number 1 is just plop down a couple more pieces, run the program 2 more times, bang, there's our 3 pieces. The other way we could do it is just use this as our master template and then make it the conventional way. So we would trace it out on a piece of Baltic birch, take it over to the bandsaw, cut it out close to the line, double stick tape this down to it, take it over to the router table, and then pattern route it so you get an exact copy of this. I'd say it's about a 50-50 in terms of which one would be faster. So it really at this point would be your preference to do one versus the other. And that's it. This is another one of those projects that if you're new to CNC, this is a great place to get started. You don't need to really know very much about how to get going, and it's very simple and you'll have a great result. And now you have the skills to build just about any guitar shape you can imagine. And one of the big advantages of this system over my old one, which is more of a traditional Fox bender system, is that when you're done, you can pull all of the forms back out, you store them in a drawer, and you don't have a big bulky form that you've got to stash on a shelf and it takes up room in your shop for a guitar you build a couple times a year. So thanks for joining us, and we'll see you next time.